Okay, so hopefully everybody can hear me, and I'm talking into the abyss. Okay, so what we're gonna do is we're going to um talk about this abacus. Hi, my name is Lynette, and we're gonna read the abacus. What is this crazy thing? Is it a toy? It is. It can be a toy. It can be a toy. It can be a car if you do this, or it could be a skateboard. It could be a massaging thing. But really, what it is we actually can use it to count. We can use it to count on the abacus, and we can also do adding, subtraction, multiplication, and division. Just so you know. So let's. The first thing that we need to do is, in order to understand how to use this little thing, is to figure out how to read it. Now it's easy to use. Simple to use, easy to understand. So we're going to count 1, 2, 3, 4. Easy, right? Just like a die, we have 1, 2, 3, 4. On the abacus, this is 4. Now you're going to maybe ask me, well, how do you do 5? Well, 5 will always be the top bead, no matter what. It will always be the top bead. Why? That's just the way it is. Do I know why? I don't know why. But that's just the way it is. We have the top bead. The top bead will always be 5. The bottom beads are always the value of 1. So when I look, this is 4 and then this is 5. So when we count, it's 4 and then 5, just to like take a look at it, right? So then we do 4 and then 5. We do 5, this is 5, this is 5, this is 5, this is 5. All of these touching this beam means that it's 5. This is the beam, the horizontal bar. This horizontal bar tells us which beads are being counted. So when we look at it, we know that when we add it like this will be counted with all these top beads. Let me readjust. Let me reset. So we have 5, and then we have 6, 7, 8, 9, right? We have 9. Now, how do I know? Because there's a top bead on top, bead on top. There's a top bead that's touching the horizontal bar, and then there's the 4 bottom beads, right? So now we can actually do is subitizing. What does that mean? When you look at the abacus, you know what it is. So like this, like this, right? Like this. When it's 3, we know it's 3. So for 3, that's what 3 looks like. Anybody have any questions, let me know. So we have 5. So I'm sorry, we have 3. So when we add this is now 8. How do I know? Because this is a value of 5. And then we have 6, 7, 8. Oh, hey, hi, Ethan. I see you. There's all these, the people are coming through, and I just happen to see you. 100 plus users. Oh my God, that's crazy. Anybody else have any questions? So this is what we're talking about, is how do you count on the abacus? No. The ultimate question is, can you do division and multiplication on this thing? And yes, you can. We just got to figure out how to get there, right? We got to go through the journey and understand how do we read the abacus first? So the first thing to do is understand how to read the abacus. Once we understand how to read the abacus, then we can actually do adding and subtracting, and then we could do multiplication, division. Why? Because multiplication, division is either fast addition, or fast subtraction, right? That's what that is. So what we have to do first is understand how do we read it, and then we're going to do adding and subtracting. If anybody else has any questions, here's a question. If I had this number, do we know what this number is? What number do we think this is? So what are we trying to do? Well, why am I starting here? The reason why I start here is because I want to have this as a starting point. So thank you, Ethan. Yes, it is 2023. 2000. How do I know? Because this is ones, tens, hundreds, and thousands. Just as we write tens, we can read it on the abacus. So we had our 9, and then we're going to do 10. So 10 is our ones and our tens. Hopefully we could see that. I'm always playing around with my camera. So that is how we know we did tens. So let's go back. When we count, it's 1, 2, 3, 4, and then 5. The top bead will always be 5. And then we have 6, 7, 8, and then 9. That's how we count on the abacus. So then when we carry it on, this is 10. And then this is 11, 12, 13, 14. I could count on. I could keep counting. 15 and then 16, 17, 18, 19, and then 20. Anybody have any questions? I'm going to continue to count. 20, 21, 22, 23, 24, 25. How do I know? Because I have 4 and then I have the 5. The top bead will always be 5 no matter what. So 25, 26, 27, 28, 29. Now let's take a look. This is 2, right? This is 20 and this is 9. So this is our ones, this is our tens, and this is our hundreds. So if I continue to count, I could do 129 and then 229, 329, and 429. How do I know that this is 9? Because I'm 6, 7, 8, 9. If anybody have any questions, let me know. What we're doing is we're talking about the abacus and how we read it. When we learn how to read it and we know how to do it, then we can go on to adding and subtracting, and then after that we could go multiplying and dividing. Because the abacus is easy to use, no, simple to use, easy to understand. Hopefully it's easy to understand. So how I have this is 5, 6, 7, 8, 9. So when we look at it, we will know that the reason why I start here is we have the dot. This dot tells me that this will be the ones place. You can be here or you can be here. It actually doesn't matter, right? It matters what you deem it, right? Just like just like where the where your house is. So you can have it here, which is the dot, could be the ones, or this could be the ones. Let me know if you have any questions about what I'm talking about. If you want me to start over, I could do that too, because it's really quite easy. And so that was the reason why I'm over here, because then I can have a larger number. Well, what happens if I start here? Well, now I can start talking about the decimals. So that means that if I started here, if I started there, which I just messed up. Oh, that was the other thing is when you're using the abacus, make sure you hold it because the beads are very loose. And it'd be really bad if you had this like huge list and then, as you do questions and then all of a sudden you mess it up. So anyways, so just as I did here, we have our ones here, the tens, the hundreds, and the thousands. Well, what happens if I did here? Well, if this was my ones, then I would start talking about the decimals, because just as we write, our ones will be our 5, this is our ones. Notice this decimal does not have a place value. It does not take up a place value. What it does is it sits between the two. Which two? The ones and the tenths. So it's just like that. The ones and the tenths. So right here is where the decimal sits. And then I'll do 7, 8, and then 9. Anybody have any questions? Anybody have any questions? Okay. Wow. Already 1,000 likes. Thank you so much for the hearts. Thank you so much for the hearts. Anybody have any questions? We're going to continue on how to read the abacus. So how do I see this? So I have all the top bead is a value of 5. So I have 5, and then this is a value of 1. So this is 6. 6. So this is 6. I'm going to add a 7. So this is 7. And then this is 8. And then this is 9. So when we look at it, it's 5.789. Anybody have any questions? We are going to continue on. So this is the reason why I'd start here. So because I started here and I have these two columns I could do, now we can actually talk about like money and stuff, right? So if I did $2.25, it would be $2.25. Okay? Are we okay? Everybody okay? Make sense? Okay. Okay. So when we start talking about it, we have our beads. Well, let's say that these color beads are too overwhelming, right? Let's say it's like, oh my God, it's too overstimulating. Well, you could use an abacus that has a single color. Now, the reason why, you could do it. And then this one actually has 13 columns. This one has 7 columns. So with the younger kids, probably about, I would say maybe like ages 3 to 5, maybe 6, maybe 7, they would enjoy these ones. But when you get to questions that are larger, it would be better to graduate the children to 13. Or you can start with one that's just 13 in general. So this one is where it's nice because it's a single color and you don't get too confused with all the colors here. It is up to you. I've been dealing with the single color for a long time. I've been teaching abacus for more than 20 years. and I was kind of like getting a little bored with the single color. So what I would do is I found this and I'm like, oh my God, this is really colorful and I like it. But I do notice that if it's too, that's not even a word. If it overstimulates, if the colors overstimulates, because there's one that is 13 columns that is just the same colors, it can be overwhelming. So you could do this one. If you choose to get something like this and you like it, you can get one that's 13 columns and it would be suffice. And these ones, yeah, so this one is 13 columns, and you can also, so because here it's bigger, I like to be in the middle. So then I have all these columns to have a bigger number, or I have all these columns to be less of the number. Now, if you notice, these ones also have dots too, right? There's a dot here and here and here. Now, why do we have so many dots? Well, it helps to understand where our separations are, where our group separations are. What does that mean? Well, if you look at it, we have our ones, tens, hundred, thousands, right? So if we have our thousands, comma, 8, 4, 3, right? So it'd be 3. We have 3, 4, 8, and 5. Notice my dots right here. This dot tells me that this is the 5,000. This is 5,000. This is 10,000. 10,000. So it'd be 10,000, and then this would be 100,000, and then over here is a million. So I could do $1 million. Like, what is it? Austin Powers. So if I wanted $1 million, this is what it would look like, because it'd be ones, right? My thousands, and then my millions. Anybody have any questions? Hey, Laura, how you doing? Welcome. I'm happy to see you here. Anybody have any questions? Wow, there's a lot of people. I don't know if everybody's are bots or these are like real people. Okay. Anybody have any questions? What we're doing is we're learning how to count on the abacus. The reason why I would use this for like the millions and stuff, probably real. I hope that they're real. I hope they're real, and I hope that, people understand. And if you have any comments or questions, let me know. I'm going to stay with this one because I'm excited. Thank you for teaching us. I'm excited that you're commenting. So it's not one way. Anyways, okay. Would you have to keep track negatives by yourself? Yes, because Abacus doesn't do negatives. So when we start doing abacus, it's usually the stuff that's here is usually positives, because just like when we do the bricks, like I know in school they're starting to do bricks. With these bricks, we don't do negatives with them, right? So it doesn't make sense. Your train of thought is so easy to follow. Oh, thank you so much. Thank you for the compliments. Thank you for the comments as well. So yeah, so, thinking about negatives, really, we don't really think about negatives. What we think about is how to take away. So one of the things is understanding how we do adding and subtracting. So the first thing we would do is we have 2 and then plus 5. If we have 2 plus 5, we know that this is 7. This is what we call simple abacus. So first thing we got to do is understand how we read it. So we understand how we read, not a problem. Now what we're going to do is we already know like our numbers, right? We know how to count forwards and we know how to count backwards and blah, 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 which is fine, which is great. That's what this is. But this is the reason why I have a preschool book, because it's for preschools to understand how numbers work. But towards the end, we actually start doing adding and subtracting. So towards the end of the book, I'm sorry, question is, so how do we don't do 106, we don't do 186 minus 194. I mean, you could, but you wouldn't, actually. It would still be backwards, and then you would put in the negative sign, right? So, what does that mean? Well, I'd still, if the question was 800, and then take away 294, I would still do it the other way, and then I would add the negative sign. So I'd be 294 take away 186, and then I would make that into a negative into the answer. So here's my question, right? The question would be 294, right? How do I know? Because I have my ones, my tens, my hundreds. So my ones, my tens, my hundreds. So 294, take away 1, take away 8, take away 6. Take away 6. Can I take away the 6? No. We will talk about this in a little bit. Take away 6. We're going to do minus the 10 plus the 4. This is something that we're going to have to memorize. Minus the 10 plus the 4. Cannot plus the 4. So we're going to plus the 10. No, plus the 5 minus the 1. Plus the 5 minus the 1. So then my answer would be 108. And then I would do a minus sign. That's what I would do. I would have to keep it in my head. So, yeah, you would have to keep your head if you do it this way. But in Abacus, none of my questions would be negative like that. I didn't even think of it that way. Thanks. Oh, you're welcome. No, thank you, Briley, for talking about it. Because, I mean, we all know and we all learn. But yeah, that's what I would do. So, if you did it negative, you would have to keep it in your head, and then you have to remember to keep the minus sign. Surprisingly, not as difficult as I thought would be. Yes, Chris! Hi, welcome back. Yes, it's not. It's simple. Simple to use, easy to understand. I'm going to keep saying that. It's simple to use, easy to understand. But wait, there's more. All right. So, let's talk about adding. So this adding, beads move. So here is the question. We have 7. How do I know that this is 7? That's brilliant. Your explanations are great. Oh, thank you so much. Some people think abacus is witchcraft. Oh, I didn't think about that. That's new. Okay, so here's my question, right? I have my 7. So I have 7 here. I'm going to go over here instead because then we could see better. So I have 7 here. And then I want to add the 1. Now, the reason why we still want to we want to just keep adding the 1, we could do it in our head because we're adults and we're big people, right? But we want to be able to do it because I want to see how the beads move. And as we notice how the beads move, we'll start to incorporate, we'll start to remember the beads in long-term memory, right? So in my head, I could see that 1 bead will move, right? I mean, we talk about abstract numbers like 1, 2, 3. The letters, the numbers themselves are abstract. However, when we look at the beads, this is concrete. So we're able to see it. And also, the other reason why is to do muscle memory. So our fingers will remember that I'm going to add the bead. Okay. So notice in this question, the reason why I focus here, minus 1. In Abacus, we don't focus on the result. We actually focus on the process. So what does that mean? We always focus in on the add-in that we're adding, and that's how we go through our abacus, because we can have like multiple add-ins. The add-ins are just the extra numbers, right? When we start doing our numbers. So one of the videos that I was coming across was they were very focused, and it's really interesting. I think in elementary school, we're very focused on the kids knowing what the result is. So one of the question was like 5 plus 3. And so notice I have a 3 here. So what? But on the video, it's like, oh, we're gonna remember that 5 plus 3 is 8. Well, let's see on the abacus. On the abacus, we can have the 5, and then we have 3. We're going to plus 3. Is there enough to add the 3? Yeah, there it is, right? So my answer is 8, which is fine. But they were really focused on the answer, which is interesting. So the next question was 7 plus 1. So I have my 7, and then, the answer is 8. So they were like, yeah, 8. Okay, so on the abacus, we have 7, and then we have plus 1. Well, what do? We have to add the 1. So we're going to add this 1, right? And my answer is 8. Not a problem. Not a problem. It's the next question that kind of like threw me in a loop. The reason why is because when we do it, it was 4 plus 4 plus 4. 4 plus 4. We know that it's 8 because in school, we all memorized what 4 plus 4 was. In school, we were memorizing that 4 plus 4 is 8. Well, in abacus, we don't memorize. Oh, that's the process of how to add the number rather than knowing what number it makes. I'm sorry, I said that too fast. Oh, the process of how to add the number rather than knowing what the number makes. Exactly. So in abacus, we don't learn our doubles. We don't memorize our doubles. What we memorize is and then notice, I don't have any more beads to add another 4. What do we do? How do we work? Oh my God. Well, in school, we're teaching the children how to make a 5. 1 plus 4 is equal to 5, or 4 plus 1 is equal to 5. I know I said that backwards, but you know what I mean. So this is what we're teaching the children. That's great. But in Abacus, we actually take it one step further. Why? Because we are now going to be able to utilize this 5. Because if you notice, we know that 4 and 1 is a pair. So if 4 and 1 is a pair, and I'm going to isolate this variable I'm going to isolate the variable. This is the 4. This 4 is exactly the same way as that 4. So I'm going to rewrite my equation, and I'm going to be plus the 4. The reason why I say plus 4 is because I want to add the 4. This is a reminder. Other one. This is a gentle reminder that we're adding a 4, right? So it's plus the 4 is equal to plus 5 minus 1. Again, this is a gentle reminder waiting to be reconnected. There we go. We're going to add the 5 and take away the 1. So what I did here is I substituted this formula into that 4. So now my answer is 8. I just remembered. I memorized what the add-in is. So let's take it one step further, right? Let's take it one step further, which is this one. This is when we're making a 5. When we make a 5, we can do this. We could do 2. 2 on the abacus. Now, where did you get that abacus? Oh, I bought it. You can get it on Amazon, or you can buy it from me. I do sell this one on my website. If you go to my link, my bio, you can sign up for a calendar, and on my website I have this abacus. Or you can buy it on Amazon. If you're looking for older kids, you can buy the 13 one, and it's single colored. It depends on how old your kids are. Is secondhand good? Is secondhand abacus good? The second hand? Like 2? What does that mean? Yeah, if it's somebody else's and then it came back, yeah, not a problem. As long as the beads are not sticky, right? And hopefully it's okay. But secondhand is fine. If it was a pre-owned abacus, that's fine too. Yeah, you're welcome, Mariana. Oh, okay, so I'm back to here. So we have 2. I'm going to add the 2 on the abacus. And then notice I don't have any more beads. So because I don't have any more beads, I need to figure out how to add the 5. So remember, what I want to do is I want to plus the 5. Because what I want to do, I want to add the 4. So what I'm going to do, I'm going to plus the 5, take away the 1. And notice plus 1 and doubles minus 1. All I have to do is remember my 4. So what I do, plus the 4 is equal to plus the 5 minus 1. And then my answer is 6. Right? So this one, the reason why I did this is because when the children, usually my students, when they're done with the preschool one, they're kind of young. I started one student at 3 years old, and he's still going through it. And so when he's finished with my preschool one, we're going to go into the making of the 5. When we're making of the 5, he'll be about 4, maybe 5. And so what I did here is I wanted to make it into a little story, because everybody likes stories. I like stories, because stories is what makes us all, kind of groove and stuff, right? So what is this story here? Well, what I noticed is there's going to be 5 cats in the tree. So I put my hand up. There's 5 cats in the tree. When there's 5 cats in the tree, that's what we're going to do. So here's my question. Here's my sample question. My sample question is 3. And then I want to add 4. So what am I going to do? I'm going to go to the cats in the tree, which I touch up to the 5, right? I add the 5. The cats. I grab 4 cats, and notice 1 cat runs away. So 1 cat runs away. And so that was the formula. You plus the 5 and you take away the 1. And that's what I did here. So my answer is 7. And it'll be the same thing with this one. So if I have 4, and if there's not enough beads to add the 5, right? If there's not enough beads to add the 4, what do? I go to the cats in the tree, right? My 5. I go to the cats in the tree, and that's what I got. So then my answer is 8. Anybody have any questions? Woo! That's a lot of people. Anybody have any questions? So what we're doing here is we're doing we are making a 5. When we make a 5, so the preschool one was talking about the simple, and then we started talking about making a 5. Making a 5 is the next stage, next phrase, next phase of abacus, next phase of adding. Because in school, we're given just the whole column, right? Oh, we got to know how to add the 2. But in abacus, there's a pattern. So what the pattern is, there's the simple, we call it simple, meaning that there's no formulas involved. So if I did this number, I'd be 6 and then plus 1. And then this one is 6. Let me do 6 and then plus 2. And notice I could do 6, 6, and then plus 3. Anybody have any other questions? I'm going to continue on. So after we do the 5, right, that's the same thing. These are the only questions that will have the 5. After we learn the 5, we need to know the minus. It's the same thing, but backwards. But it's backwards. Like you need to go right to go left. You know, like in Lightning McQueen, you need to go right to go left. It was like, what? That doesn't make any sense. But this one does. This one does. Why? Because we need to minus. When we minus, we need to. When we add the 5, we need to know how to minus. What does that mean? So we started off with understanding that plus the 4 is equal to plus 5 minus 1. Well, there is a reverse to that. There's a inverse to that. The inverse is minus the 4 is equal to minus the 5 plus the 1. So how does that work? Just like add, I'm reconnecting. There we go. So there we go. So I have 8. So the question is 8 and I want to take away 4. Notice I have a minus 4 here. So beats to take away the 4. I don't have enough beats. 1, 2, 3. So how do I take away 4? In my previous formula, these are the other things that the kids have to memorize. The kids have to memorize minus the 5 plus the 1. And again, it's the same concept. Minus the 5 and then add the 1. And so then my answer is 4. Anybody have any questions? So does that make sense? So in school, not in school, in Abacus, we teach. Once we teach how to add, we need to teach how to minus. Because it's just one of those things like, because then we can go into understanding how, kids are all playing video games. So we assume that there is a plus here. When we do the minus, it would look like this if we were to follow the logic, minus 5. And then what are we going to do? We're going to isolate this variable. We're going to isolate this variable. So we take this 1 and we move it to this side. So it would be minus 4 is equal to minus the 5 and plus the 1. So does anybody have any questions? Does that make sense? Yeah. Okay, cool. Cool. Silence is golden. All right. So what are we going to do now is we're going to understand how to make a 10. So that's the next step is how do you make a 10? We all know in school, we're starting to teach children how to make a 10. Plus 1, 9 plus 1 is equal to 10. Or 8 plus 2 is equal to 10. We are teaching children this already, and that's great. This is part of the Common Core, I'm assuming. I remember when my kids went to when my kids started learning Abacus, and then all of a sudden we switched over to Common Core, and my kids were like, okay, whatever. But it was easy because in Abacus, we do a lot of the Common Core stuff, whereas in before, just as we do this with the minus 1 minus 4 is equal to 5, we do the same thing with the 9 and the 10. So if I want to know how to plus the 9, I will plus the 9 is equal to plus the 10 minus the 1. Notice that there's a pattern. So it's interesting to see how the pattern, that in Abacus, we definitely see patterns. So what I want to do here, I want to add the 9. So in this one, I'm adding a 9. Right? And it's the same concept. So here is my sample question. With my sample question, I have 4, and then I want to add the 9. I don't have any beads to add the 9. So what do? I have to go, when I want to add the 9, I will plus the 10 minus the 1. So here in this concept, the only thing that's different is knowing that what plus 10 means. Plus 10 only means to go to the next column. That's all it means. Okay? And then what I want to do is I want to plus the 10 take away the 1. That's how I add the 9, because that's where I'm at. I'm going to add the 9 right here. So all I got to do is plus the 10 minus the 1. I'm going to plus the 10 and then take away the 1. And my answer is 13. Make sense? Are we all right? Okay, I'm going to continue on with my adding of the 10. Why? Because it's an interesting concept. So what we just is because we don't use terminologies, all the math terminologies in Abacus. So it's taken me a while to figure out what all the terminologies are. So here in this concept, we're actually doing grouping or carrying over. That's what the plus 10 is, which is interesting. And I was like, oh my God. So we actually introduced the idea of grouping and regrouping when we do the 10 and the takeaway 10. We also do borrowing as well. So it's interesting to know the concepts that are being added. So here's the question, right? So if I did 40 plus 91, let's do that, right? I'm going to do is 40. I'm going to put 40. And then I'm going to add 90 and I'm going to add 1. I'm going to add 90. Now, when we talk about it when we talk about it in Abacus, we don't say plus the 90 is equal to plus the 100 minus 10. We don't say that. We just say plus the 9 is equal to plus the 10 minus 1. We know we're in this column. We know we won't go anywhere else. So when we go here, we're going to plus the 10. Notice I'm at the tens, and then when I say plus the 10, I just go to one column over. I don't say plus the 10. So when I say plus the 10, I'm only going to add this 10 right here. So I'm going to add the 10 here, and I'm going to take away the 1. That's what that means. And that's why it's crucial to boil down to the simplified version of the formula. We don't say plus 90 equals to plus 100 minus 10. That's way too confusing. It's too many numbers, right? Oh, and then I have to do the final one, which is add the 1. I'm going to add the 1 here. So then my final answer is, anybody know what this answer is? Let me know in the chat what number you think this is. Let me know in the chat what number you think this is. So if this is my 1s, my 10s, and my 100s. Thank you, Ethan. Yes, 131, if that made sense. So if anybody have any questions, Woo! 7,000 hearts. That's amazing. Anybody have any questions? Hey, Tara. All right. We are going to continue on with, so that was the one thing. And then if you notice, I don't know if anybody can see me. Okay, so plus the 9 is plus the 10 minus the 1, plus the 10. Notice when I plus the 10, this is the carrying over, right? I put it in quotes because we don't call it like that in Abacus. We just say plus 10. But in mainstream school, we call it carrying over. And then we plus the 1. So this right here, we just did a carryover, or we did a regrouping, which is interesting, right? And so now let's do it the other way. We have, we are going to do borrowing, which is interesting, but we don't borrow. We actually just take it. We just take. So what is it? It is 14. What am I going to do? 14? I want my MTV. 17. We'll do, no, not 17. We'll do 18. 18 minus 6. 18 take away 6. So we have 18, 1 and 8. 1 and then 8. And then I want to take away the 6. When we take away the 6, is there enough? No. Well, what do? Well, we know that our formula will be minus the 6 is equal to minus the 10 plus the 4. 4 and 6 what makes 10. 4 plus 6 makes 10. But remember, when we do minus, we need to do minus 6 minus 4 is equal to minus 10. When we rewrite this, it will look like this. That's what it is, right? Because we're moving this 4 over here. So when we rewrite it, that's what it is. Now, what are we doing? In mainstream math, we're going to borrow. But in Abacus, we just say minus 10. That's all we say. So what we're going to do is we're going to minus the 10 plus the 4. Ooh, what did I do? 16. Is that right? No, 18. Sorry, 18. 18 plus 4. What? Oh, ha ha, sorry. I was doing the wrong one. Well, it's okay. That's fine. We're going to 18 plus 4. Now we're going to do a two-step as well. So minus the 6 is minus the 10 plus the 4. No, wait. No. Minus 6. Because 18 take away 6. We know how to do it, right? Because we just take away the 6. There's no formula involved. You see that? My bad. Wrong one. Wrong question. Wrong question. Yep, sorry, wrong question. I needed to do this one. Because I needed to do the plus 10s. I did the wrong one. So it is 13 minus 5. We'll do that instead. Because why? Because we do plus the 5 minus the 5 is equal to minus the 10 plus the 5. So we want to do is we minus the 10 plus the 5. What? We have our 13, and notice we don't have enough beats to take away the 5, right? We can't take away the 5, so what are we going to do? We are going to take away the 10, which is borrowing. In mainstream math, we call it borrowing or regrouping. We take away the 10, and we add the 5. And that's what we do. And our answer is 8. Make sense? So then I had one parent, I had one parent saying, well, I want my kids to know how to add the 5, plus 8 and 5, and 5 and 8. Is it easy? And it's like, yes, it is, but there's a step to it. And she's like, what do you mean? Well, we can do it, not a problem. So here's the question, right? It was 8 plus 5, and then 5 plus 8. The answer would be the same, but it's the process that we're trying to figure out. Why? Because it's the second add-in that we need to remember. The second add-in is what's going to give us is going to tell us whether or not we're going to use more formulas or not. So when I do 8, I do 8. And now I have the 5. Do I have enough beats to add the 5? No. So what do? I'm going to plus the 5 is equal to plus the 10 minus the 5. So what I'm going to do is I'm going to plus the 10 and then take away the 5. So my answer is 13. That's fine. Now the next question was 5 plus 8. How is that different? Well, let's take a look at it. We do 5, and now we're going to plus the 8. Is there enough to plus the 8? No. So when we plus the 8, it's plus the 10 minus the 2. That's the formula that all the kids have to memorize. So what we're going to do is we're going to plus the 10, and then we're going to take away the 2. Well, this is where the two-step equation happens. Just like in algebra, we start doing two-step equations. Abacus is the gateway to complex math. Because in Abacus, we actually start introducing how to do a two-step equation. If you notice, I don't have any more beats to take away the 2. So what do? I need to minus the 2 is equal to minus the 5 plus the 3. This is a making of a 5 formula that we need to remember, right? So what does that mean? I minus the 5 and I plus the 3. So then my answer is 13. Even though the answers are the same, again, it's not about the goal, it's about the process. It's about the journey, not the goal. Anyways, I cracked myself up. So if that makes sense, anybody have any questions? So that was doing the 10s. That's what we're doing. So if you know how to make a 5 and how to make a 10, then everything is golden. And then it just figures out, like, how do they all fit? How do all the pieces fit together? And they fit in different ways, right? So are we okay with this concept, with the plus 5 and the plus 10? Put 1 in the comments if you're okay. Put 2 if you don't know, or put question marks. Thank you, Laura. Okay, so we do the two-step, right? But two-step can be more two-step. So we did one two-step over here. Let's do another two-step. What does that mean? Well, the question is 49 plus 3. That's easy, no problem. So we have 49. Now I want to add the 3, right? When I add the 3, what can I do? Well, I can't add the 5 because we're already using it, right? So what do? We need to plus the 10. Those are the only two formulas that the 3 has. Either plus the 5 or plus the 10. So when we do 3 plus 3, it's equal to plus 5 minus 2, or plus 3 is equal to plus 10 minus 7, right? That's how we make it. Now, those are the only two options you have to add the 3. We cannot do the plus 5 because we're already here. So what we're going to do is we're going to plus the 10 minus the 7, plus the 10. Plus the 10. Notice I cannot plus the 10. Wait a minute. If you can't plus the 10, what do? We know this. We know what? If we want to plus the 10, which is the same as plus the 1, we can plus the 5 minus the 4. So again, it's adding a 5 formula into the situation. This is our two-step equation. And it goes like that, right? Because this 10 is the same thing as the 1. So now what we're going to do is we're going to substitute this into here. I'm going to add the 5, take away the 4. And then minus the 7. And I take away the 7. So then my answer is 52. So that's what I'm saying. Like, there's more to adding and subtraction. There's more to it. It's just what's the path to get there? So that's another two-step. Does that make sense? So the going back to it, as long as you understand how, like cream and sugar or butter and sugar, right? How do they fit together? What are you trying to make? Are we trying to make a cake, or are we trying to make sauce, right? So we have our ingredients, which is a 5 and we have a 10. Just like with when we're baking or when we're making something, right? Or one of our fundamentals is what? I think onions, and I know I cook a lot with onions and garlic, right? So when you cook with onions and garlic, how do you fit it all in? Do you put it? It all depends, right? Same thing with adding the 10s and making the 10 and making the 5. Does that make sense? So there can be there's more, there's an advanced understanding when you start doing this, but it starts with the first thing to do. It starts with simple stuff. When you start doing it simply and you understand how everything works here, then you can go up to doing the two-step in another way. So we did the two-step here. Now we do a two-step further down when we're doing a 49. We can do another, like a little bit more complicated, which is 9 plus 99 plus 3. We'll keep it as 3. Why is this more complicated? Well, we have 99 and we want to add the 3. Same thing. We talk about this. Do we have enough? No, we don't have enough for the plus 5, but we know we have to do the plus 10. This is where it's again two-step. What does that mean? I want to add the 3 plus the 10 minus the 7 plus the 10. This one was a 5 formula. Now I already have the 5, so I can't do that kind of plus 10. 1 also has two ways. Plus 1 is equal to plus the 10 minus 9. Or plus the 1 is equal to plus the 10 minus 4. But I already have a plus 5 here, so I can't do it. So I got to do this one. So now what am I going to do? I'm going to plus the 10 minus the 9 minus the 7. Are we okay with that? So if I want to add the 3, so this is what you have to do, is you have to keep track. That's why you have to get those formulas solid. Those are the only formulas you need to know. But as you go through it, you can actually, fit them in. They're quite versatile. So we're going to go back. I'm here. Plus 3 is plus the 10 minus the 7. I cannot plus the 10, so I need to plus the 10 minus the 9. So I'm going to plus the 10, and I take away the 9, and I take away the 7. So you have to keep track of all of the things you're trying to do. And it's a lot about just keeping a checklist in your head. But that's why we start going through the questions slowly and just keep moving the beads so we know what we're trying to do. The more you see the beads, right, the more you'll notice that there is a number pattern. So if you notice, when I want to plus the 9, when I want to plus the nine or the 1, I notice I have to take away plus the 10 and minus the 9. That's the pattern that you'll see. If I want to add the 1, I'm going to plus the 10 minus the 9, right? Same thing with the 9. If I want to plus the 9 here, it's plus the 1 plus the 10 minus the 1. So this is the pattern that we're seeing. And you see it. It's just math. It's just math. Yeah. Me. Whew. Anybody have any questions? Have any questions? Or it could just be me. All right. There's no more questions? So we had the 9. Oh, so my answer is 100. So we did 102. 102. 102. 102. So this is how it's a more, what do you call it? More, not complicated. It's just another two-step, but it's just a different way of doing a two-step. Anybody have any questions? Oh, hey, Ethan. I don't know. I think it's my connection. I keep going back and forth. Whew. I don't know if there's 4 people in the room or if it's just me. Anybody have any questions? No more questions? We can continue on. 4. Oh, yeah, there are 4. Okay, good. Yeah, because I don't see the people because I think I'm on my desktop. So, okay, so going back, do we have any questions about what I just said? Yeah, so that's why, like, doing the numbers, it does depend on where you're going to go. I mean, again, it's the other way too. It's the same way. We just need to know how to do it. So here, if we did minus, right? So it'd be 105. There we go. I don't know when I'm reconnecting. I don't know if anybody can see me. So here, 105 minus 9. Again, this is a more than a two step. How do I know? Because I want to minus the 9. Oh no, this is fine. Minus the 9 here. Well, what can I do? I need to minus the 10 plus the 1. Minus the 10. I don't have any beads to minus the 10, right? So what do I want to do? Minus the 10. Nope. I want to minus the 9 is equal to minus the 10 plus the 1. That's what we're doing here. Yeah, that's what I thought. I thought so because I see that I'm reconnecting all the time. So we just had an earthquake too. So, anyways, so we have minus the 9 is equal to minus the 10 plus the 1. That's what we're trying to do here. So I'm going to minus the 10, but notice I cannot minus the 10 here, right? So what do? I can minus the 1 is equal to minus the 10 plus the 9. So now this is my other two-step, but it goes into here. You know what? Okay, I think this is not a good day to go live. Maybe after this I'm gonna end it just because I'm lagging all the time and it's kind of difficult. So last question, because we gotta always end off with like understanding our question, right? So 105 take away 9. So minus the 9 is minus the 10 plus the 1. Minus the 10, there's not enough. So what do? I need to minus the 10 plus the 9 plus the 1. How did I get that? Because what we're trying to do, we're going to try to minus the 10 over here. I don't have enough. So this is where borrowing comes in. So I'm going to minus the 10 plus the 9 and then plus the 1. So I'm going to apply minus the 9, minus the 10 plus the 9 and then plus the 1. So this is probably a good time to be like, okay, if there's no other questions, if I'm lagging it, this is not a good experience. So if anybody has any questions, let me know. If not, I am going to sign off. It was kind of exciting for a while it happened, but I kept reconnecting and it was kind of bothering me. It could just be the weather. It's starting to rain as well. If anybody has any questions, anybody? Bueller? All right. If nobody has any questions, I'm gonna sign off. The connections are kind of bad, and we'll see if anything else after like died. All right. Okay. Okay, everybody. Thank you, guys. Everybody, thank you again for joining. You're strong. You keep teaching while you're lagging. Yeah, well, yeah. But it's not a good experience if I'm lagging and then I go through it and somehow I skip a step and you're like, wait a minute, what's going on? So we'll try again tomorrow morning. You know what? We'll try again tomorrow morning. It is. Yeah, I'll see you tomorrow. Actually, it'll be like nighttime for you. Um, but yeah, I mean, unless Ethan, unless you have any other questions, I am gonna sign off. Maybe I'll figure this out. Yeah, reconnect. All right. Thank you again for joining me. It was fun. It was fun. It was fun while it lasted.